Rounding decimals. In this lesson, we are going to practice rounding decimals, and we're going to use what we already know about rounding whole numbers and apply it to decimals. For the most part, it's the same, with one little difference that I will explain here. Let's just do a quick review of what we did when we were rounding whole numbers. Let's say I just wrote down a sample problem here of 5,347. Okay. If I was looking at this number and rounding to the thousands place, I'm really asking myself, is this number closer to 5,000 or 6,000? In this case, thinking about where it falls on a number line, we would say, well, you'd round this down to 5,000. And the method that we practice is we'd underline the digit of the place value that we're rounding to, in this case, the thousands place, look at the number to its right, which is a 3, and ask ourselves, is the number to the right of the place value I'm rounding to 5 or more? If it is, then I raise the score of this and zero out the rest of these digits. If the digit to its right is 4 or less, then I give this digit a rest and, again, zero everything else out. Now, let me show you how this is slightly different if I make this a decimal. Now, imagine this decimal, 5 and 347 thousandths. Imagine where it falls on a number line. If you visualize this as being somewhere between 5 and 6, you're correct. Is it closer to 5 or closer to 6? Well, it'd be somewhere right about here, wouldn't it? So it'd be closer to the 5 than the 6. Now, if we were going to round this decimal to the nearest whole number or the nearest ones place, then I'm going to underline that digit of the place value I'm rounding to. I'm going to look at the digit to its right, its neighbor. Is this 5 or more? No. This is 4 or less. So I give this a rest. And then if this was a whole number, I would zero all this out, wouldn't I? And I would call this rounded version 5 and 0 thousandths. But in the case of decimals, it's okay to just call this plain old whole number 5. In other words, we agree that the digit to the right of the place I'm rounding to is 4 or less. We agree that we're going to give this number a rest, meaning leave it alone. Instead of turning all of these into zeros, I just drop them. And so I end up with 5. Let's apply that to our practice problem. For this first set of problems, we're going to round to the nearest tenth. So think about your place value chart. You got ones is the place value. That would be the lowest in the land of whole numbers. And you've got your decimal point. And you've got tenths. You got hundredths. And then you got your thousands here. The name of this decimal, of course, is 29 hundredths. And if I'm going to round to the nearest tenth, I'll underline the digit that's in the tenths place, which is a 2. I'll look at the digit to its right, which is a 9. 9 is 5 or more. I'm going to raise the score on the 2. The 2 becomes a 3. But instead of turning this to 0, I'm just going to drop everything that's to the right of what I've underlined. And 29 hundredths gets rounded up to 3 tenths. Now, is this equal to 30 hundredths? Yeah, it is. But I don't need that extra 0 there. 63 hundredths, rounding it to the nearest tenth. Underline the tenths place. Look at the number to its right. The 3. This is 4 or less. Give this 6 a rest. Drop everything to the right. 63 hundredths gets rounded down to 6 tenths. 359 thousandths. Underline the tenths place. Look at the number to its right. It's a 5. 5 or more means we raise the score on what we've underlined. 3 becomes a 4. drop the rest of the digits. 359 thousandths gets rounded up to 4 tenths. 13 thousandths, underline what's in the tens place. Look at the number to its right. This number to the right is 4 or less. I give this a rest and drop everything else. And even though this sounds weird, I'm rounding it down to plain old 0. I could call this 0 and 0 tenths, but why would I? It's plain old 0. Moving on to the next row, here we're rounding to the nearest hundredth. 460 thousandths, I'm going to underline the digit in the hundredths place. Look at the number to its right. The number to the right is 4 or less. I give this a rest, drop everything else. 460 thousandths gets rounded to 46 hundredths. In other words, it doesn't change its value at all. 256 thousandths. Underline what's in the hundredths place. The number to its right is 5 or more. I'm going to raise the score on what I've underlined, drop everything else to the right. This gets rounded up to 26 hundredths. 63 thousandths. Underline the digit in the hundredths place. The number to its right is 4 or less. This gets rounded down to 6 hundredths. 503 thousandths. Underline what's in the hundredths place. Look at the number to its right. This is 4 or less. I'm going to give this 0 a rest and drop everything to the right. This gets rounded down to 50 hundredths. In this next section, we're asked to write an estimated answer for each problem and then find and write each exact answer. So with the estimate, of course, we want to use rounding to come up with numbers that we can make a calculation using mental math. So let's see this in action. First whole number multiplication, 9 multiplied by 47. You know what? I'm going to take the 47 and round that to 50. I'm going to call this 9 times 50. And then I know how to do this. Cover up my 0. 9 times 5 is 45. Add my 0 back in. 450 is my estimate. Now to solve this for real, I'll just need to find a place to do a side calculation. Why not right here? Put the larger number on top, 47 multiplied by 9. 9 times 7 is 63. The 3 comes down, 6 gets carried. 9 times 4 is 36, plus the 6 is 42. I get an actual answer of 423, and that is reasonable and is close to my estimate. I knew my estimate was going to be a little higher than the actual because I rounded 47 up to 50, but very much in the ballpark. Moving on, I'm going to round 8 and 2 tenths down to 8. I'm going to round 2 and 7 tenths up to 3. My estimate here is 24. Now to solve this, 8 and 2 tenths multiplied by 2 and 7 tenths, how many places do I need to push the decimal point altogether to clear them out? Whoop, whoop. If you said 2 pushes, you're correct. Let's find a little place to do our calculation. 82 times 27. Make a note to myself that I got to come back in 2 spots at the end to insert my decimal point. And let's begin. 7 times 2 is 14. 4 comes down, 1 gets carried. 7 times 8 is 56, plus the 1 is 57. Now my first row is complete. Add my 0 placeholder and do my second row, which is going to be 82 times 2. 2 times 2 is 4. 2 times 8 is 16. Second row is complete. Add up my columns. 4 and 0 is 4. 7 and 4 is 11. 1 comes down, 1 gets carried. 1 and 5 is 6. 6 and 6 is 12. 1 gets carried. 1 and 1 is 2. And remember to come back in 2 places from the end. Pew, pew. 22 and 14 hundredths is my actual. And yes, that checks out nicely with my estimate. Next problem. 5 and 75/100 multiplied by 8/10. I'm going to round this up to 6. I'm going to round this up to 1. And my estimate is 6. How many places do I need to push decimal points out altogether? Whoop, whoop, whoop. If you said 3 pushes, you are right on. Let's rewrite the problem as 575 multiplied by 8, knowing that I'm going to come in 3 places from the end to put my decimal point. 8 times 5 is 40. 0 comes down, 4 gets carried. 8 times 7 is 56 plus the 4, 60. 0 comes down, 6 gets carried. 8 times 5 is 40 plus the 6, 46. Come in, pew, pew, pew. I get 4 and 600 thousandths, or I could simply show that as 4 and 6/10. These 2 zeros are not necessary. Checks out with my estimate. Number 12, 8 and 8/10 times 8 and 5/100. Let's use rounding. This decimal, I'm going to round that up to 9. This decimal, I'll round it down to 8. 9 times 8 is 72. Come over here. How many places do I need to push the decimal point out altogether to clear them? 1 push, whoop, whoop, whoop. 3 pushes altogether. And let's work it out. 805 multiplied by 88. Make a note to myself to come in 3 places at the end. First row, 8 times 5 is 40. 0 comes down, 4 gets carried. 8 times 0 is 0 plus the 4 is 4. 8 times 8 is 64. First row is complete. 0 placeholder comes down. Second row is going to look a lot like the first row, isn't it? 8 times 5 again is 40. 0 comes down, 4 gets carried. 8 times 0 is 0 plus the 4. 8 times 8 is 64. Second row is complete. Add up my columns. Come in 3 places. Pew, pew, pew. 70 and 840 thousandths, or I could simply show that as 70 and 84 hundredths. That extra 0 at the end is not needed. Checks out very nicely with my estimate. And let's finish up with problem 13 here. First, come up with an estimate. I'm going to take this decimal and round it down to 1. I'm going to take this decimal and round it up to 1. 1 times 1, of course, is 1. How many pushes to clear decimal points out altogether? Whoop, whoop. Whoop. 3 pushes will do the trick. Side calculation, 117 multiplied by 9. 9 times 7 is 63. 3 comes down, 6 gets carried. 9 times 1 is 9 plus the 6. 15. 5 comes down, 1 gets carried. 9 times 1 is 9 plus the 1 is 10. Come in 3 places. Pew, pew, pew. Final answer is 1 and 53 hundredths, just slightly larger than our estimate.